Are there any real advantages to assigning more cores to VirtualBox? I have an 2.8 quad-core i7 with a VirtualBox. I have the option of assigning up to 4 cores to a guest machine, but I have only been doing 2. What are the advantages/disadvantages of assigning more cores to a guest? VTW, I am still able to play StarCraft 2 on Ultra settings all the way while running 2 guest OSes, Win 7 and Ubuntu, and same goes with BFBC2, my stress testers. How does the i7 react to uneven loads across cores?
The virtual cores you assign to a VM are available to use in multiprocessing within the client host. If you assign only one core to a VM, then there is no chance by the guest host to distribute load across multiple cores. So let's assume some practical scenarios. Host with 4 CPUs, guest assigned 1 CPU. Host machine running 4 physical cores. Client host within VM assigned 1 core. In this case, the guest OS will be able to use only 1 core. Therefore, if you run a multi-threaded application which scales well on multiple cores, it will still run on 1 core only. Therefore, all threads on the guest OS have to share 1 physical core. Running a guest OS in this setup which fully loads the CPU will yield a host OS CPU load of 25%, 1 out of 4 cores loaded on host. Of course, you can still have CPU-consuming tasks running within your host OS and make use of the remaining 3 cores. Host with 4 CPUs, guest assigned 4 CPUs. Host machine running 4 physical cores. Client OS within VM assigned 4 cores. In this case, you can run while scaling multi-threaded applications within the guest VM which can make full use of all 4 virtual CPUs. VirtualBox will use 4 physical cores to process tasks scheduled within the VM, and therefore your host CPU load could reach a maximum of 100% usage. So what setting should you choose? The answer to this question depends pretty much on what you would like to do. In some cases it might be useful to assign all cores to a VM, or even running multiple VM having each one the full amount of CPUs assigned. In such cases a VM can make full use of the whole processing power of the host. If more CPUs are assigned to VMS than actually physical present, then the VMS will be impacted by load on different VM. To prevent this, you might dedicate some cores to specific VMS. For example, running 2 VMS with 2 CPUs assigned each on a 4-core node could help that each VM gets 2 dedicated CPUs, assuming there is no load imposed by host OS which takes a part of the processing power too. Does it have negative impact on my host to assign all cores to a VM? Again, this depends on the software run. If you run in a VM which is idle, no CPU-intensive programs run at all, the load imposed by this VM will be near to 0%. You can even run 10 VMS in parallel and still experiencing a host CPU load of close to 0% if all VMS are idle. How does the CPU behave on uneven load? Well, CPU load distribution heavily depends on an OS-specific built-in component called the scheduler. For Windows XP, the scheduler tried to round-robin load all CPU cores. So running a single-threaded task with full load on a quad-core CPU would have yielded 25% load on each core. Unfortunately, this has proven to be bad for modern CPU power management. For modern systems, it's even an advantage if one single core is loaded up to 100% before the second core even gets involved. The reason is that as long as there is not sufficient load to fully use up one core, the other cores can remain in deep sleep mode to save energy and reduce heat dissipation. For some CPUs like Intel Core i-series and newer AMD Bulldozer, this is even more interesting, since in case only a subset of the cores are used, the unused ones are switched off. This reduces the power consumption of the CPU. Both Intel and AMD start to use the thermal and power consumption budget then to overclock the cores which are active. So this can give single-threaded applications, which cannot be distributed to multiple cores to work on a task in parallel, a boost. However, when all cores are active, then most of these boost technologies do have only a small effect on processing power, since the all cores active situation is exactly the situation the CPU was designed for. But when you switch off some cores, then the remaining cores can run overclocked without causing the chip to run more hot, or consuming more power than in case all cores are active. So the answer is that your Core i7 very well handles uneven load on single cores and might even provide a performance boost to single-threaded applications. However, this boost is within the range of a few percent, while actually multi-threaded applications which can distribute the load across multiple CPU cores can be boosted by factors x2 on dual-core, 4x on quad-core in optimal case. So multi-threading is always providing more power in terms of combined CPU power than single-threading combined with clock boosting.
In a comment elsewhere, VirtualBox expert Mpak writes, "In real life, a lot of operations are disk-bound or network-bound. Only a minority of operations are CPU-bound. The more cores you create for your VM, the more overhead these cores will cause, due to context switches. In practice, the ideal choice is usually to assign 2 cores to each VM. If you need to run CPU-intensive tasks all day, such as video encoding, don't run these tasks in a VM. Run them on the host OS, they'll run faster there."
Visual